In this video, we're talking about reading and writing in scientific notation. This is pretty much a continuation of what we've been working with exponents and multiplying with factors, so it shouldn't be too terribly difficult with what we're planning to do. But first, know that scientific notation is a number that is written as a product of a factor and a power of 10. And the factor must be between 1 and 10. All right, so let me give you an example of what I mean. If I were to write scientific notation, I could say 1.3 times 10 to the 5th power. Notice that this is my factor, the 1.3. This is between 1 and 10. Another example would be 8.9 times 10 to the negative 6. This is between 1 and 10. And if I had one like this would not be scientific notation because this factor is 14 and I have to have it between 1 and 10. So I would have to do some rearranging on this. And we'll talk about how to rearrange this in another video. So that's really all scientific notation is where I take a really, really large number such as this and I rewrite it so that it looks like this. I'm going to just do it real fast. 1, 2, 3, 4, 5, 6. 1.4 times 10 to the 6. All right. So I rewrote that, a really, really large number, into scientific notation. And I could also have a really small number. Notice this, okay? This is a decimal. It's a really, really teeny tiny number. And I'm going to write it in scientific notation. 1, 2, 3, 4, 5, 6. Oops, that was pretty cool. All right, didn't know I was going to do that. And so I rewrote both of these. So the question is how did I do that? So now that we've talked about these different things, let's just look at a couple of problems here and take a moment and see what you have. So this very first set is asking if this is written in scientific notation. Explain. So just go through these 6 on your own and tell me whether it's written in scientific notation. The only 2 that are not written in scientific notation are 1 and 5. And the reason for it is because this factor is not between 1 and 10. And neither is this one. This is actually less than 1. All right? So now what we want to do is to look at how we go from scientific notation and change it to standard form. So let's look at our rule. All right, so just to kind of go through it, I've given you some rules. So first off, changing from scientific notation to standard form. We're going to just concentrate that right now. So the first thing you need to do is pay attention to the exponent. Pay attention to the exponent. I have this big bold. If the exponent, which would be this 3, if it's positive, it will make a large number. And you will have to move your decimal right based upon the exponent. If it is negative, it will make a small number or a decimal, and you will move your decimal left based upon the exponent. So let's just go ahead and give you some examples to what this is talking about. Now that we've kind of gone through the rules, let's actually put some application to this. So it told me that I need to pay attention to my exponent, which in this case is a positive 9. That means that I'm going to have a really large number. It's a positive 9, and it's going to make a large number. And it tells me to move my decimal according to that number. So if I look at this, my decimal is technically after the 4, right here. All right, and it's telling me to move to the right 9 times. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And wherever that I did a jump, I'm actually going to put a 0 in between the little humps here. So every time I made a jump, I have a 0. So I'm going to put a 0 here, a 0 here, a 0 here, 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 and here. All right, now I've done that, I can just rewrite this. So I have 4, 0, 0. How many zeros I got? 3, 4, 5, 6, 7, 8, 9. 3, 3, 4, 5, 6, 7, 8, 9. So 4 times 10 to the ninth, when written in standard form, looks just like this, okay? And this would be my millions, this would be my billions, so I think this is trillion. All right. Now, let's look at number 8. It's the same concept. I need to look at my exponent, and this time it's a negative exponent, so it's actually telling me to move my decimal to the left, and my decimal is right here. So I'm going to move to my left 5 times. 1, 2, 3, 4, 5. So every time I did a jump, I've got put a 0 in its place. And I'm going to rewrite this as 0.0, and I got 4 zeros, 2. All right, this is now in standard form. So let me do, I'll do one more with you. So this one right here is 3.7 times 10 to the 6. So I know my decimal's here, and this is a positive 6, so I'm going to move it to the right because it's going to make a very big number. Whereas in this one, which was a negative exponent, made a very small number, a very small decimal. So I'm going to go 3.7, and I'm going to move my decimal to the right 6 times. 1, 2, 3, 4, 5, 6. So my answer would be 3,700,000. So why don't you try 10, 11, and 12 on your own? So what you should have got for 10 was a very, very small decimal because this was a negative exponent, and I got 0.00412. The next one I was a positive exponent, so that means that it was a very large number. So in this case, I have this number right here. What do we have? Thousands, millions. So this was 76,200,000,000. And this one, I'm not even going to pretend to know how to say, but just know this. There is a decimal followed by 11 zeros, followed by 9908. So I'm not even going to pretend to know what this is called, all right, off the top of my head. So that's really all taking from scientific notation to standard form is just to remember those rules. If it's a positive number, you're going to have a large number such as this. And if it's a negative exponent, you're going to have a really tiny decimal such as this. All right, so I'm going to leave 13 to you. But what I do want to do right now is we're going to actually look at the next piece of it. And we're going to write the number in scientific notation. So now we're going to reverse that process. So now I've given it to you in standard form, and our job is to write it in scientific notation. Well, let's look at our rules that I gave you. So it says, if a large number, you make the factor by moving the decimal left. Your exponent will be the positive number based on how many times you moved. And then the next piece, if it's a small number, decimal, you make the factor by moving the decimal right. Your exponent will be a negative number based on how many times you've moved. So let's go back and just kind of think this. So I have a large number here. It's a large number by itself. It's really big. So automatically I should know that I'm going to have times 10 to a positive number, okay? Because this is a large number, so my exponent will be positive. Now, in order for me to know what my factor is, I need to isolate my decimal. So I know my decimal is right here, and I'm actually going to move it to where that my factor is between 1 and 10. So I'm going to go 1, 2, 3, 4, 5. And notice this, if I had stopped here, my factor would be 42, but I need to go one more time to make it 4.2. So I've moved it here. So that was 1, 2, 3, 4, 5, 6 jumps. So that means that my exponent is going to be a positive 6, and my factor is 4.2. All right? Now look at this one. I have a decimal number, so automatically I know that this is going to be a negative exponent because it is a small decimal. So I'm going to have a negative exponent. My job is to take this decimal and move it so that my factor is between 1 and 10. So where I'm going to move it will be right here to make 3.8. So how many times did I jump? 1, 2. So I have 3.8 times 10 to the negative 2. All right, so let's do another one. Let's do this one, okay? So my job, I already know by looking at it, it is a small decimal. So I'm going to have 10 to the negative power. I don't know what that power is yet. And I also know that my factor has to be between 1 and 10. So I need to put my new decimal right about here. So that's going to be 8.08 because this is between 1 and 10. Now, how many times did I move my decimal? So let's count. 1, 2, 3, 4, 5. I'm going to double check that. 1, 2, 3, 4, 5. So this would be a negative 5. I'm done. So why don't you try 3, 5, and 6 on your own? What you should have got for 3 was 6 times 10 to the 5th. For 5, 7 times 10 to the negative 4. And for 6, 2.901 times 10 to the 10th power. All right, so I'm actually going to leave you some challenge problems on this one. So your job is to order the numbers from least to greatest. There's multiple ways that we can do this, but I might make a suggestion is either A, you can write them all out into standard form. That will be absolutely fine, and you can see what number is bigger than the other. So that's one way to do it. The other way to do it is to really pay attention to your exponents. Your exponents are a big key. So I'm not going to give you the answers in this video, but so I'm going to give you 7 through 11 as challenge problems, and I will see, and also don't forget, excuse me, I forgot to mention this, also don't forget number 13. So I'm giving these to you as challenge problems, and I will see you in the next video. Bye-bye.